Welcome back to another exciting class, Year 10. Today we're going to be graphing some exponentials. Now, exponentials are unusual graphs. You haven't seen a lot of them before. They're in the form y equals a to the power of x. So if I actually write this down, that's an exponential. I could write this down. That's an exponential. I could write this down. That's an exponential. Now that's all you're going to be doing, graphs like that, but they get a bit tricky. I could write this down. That's an exponential. I could write this down. That's an exponential. So exponentials are graphs where the x is part of the exponent. Another name for an exponent is a power or an index. Remember, we've done indices. Indices just mean we're dealing with powers or exponents. So when you're graphing exponentials, you are graphing something where the x is part of the power or the exponent. So x is the power or the exponent. Now, exponential graphs will always have a horizontal asymptote, and you need to mark the asymptote onto the diagram when you draw it. Now, an asymptote is a line that the curve gets close to, but it will never ever reach it or touch it. So I'm going to show you what an exponential graph looks like. We'll graph one in a moment, but this is what exponential graphs typically will look like. Something like that. What happens is out here to the right, it just keeps climbing, and to the left, it just keeps getting closer and closer and closer to the x-axis, but it never touches the x-axis. And as a matter of fact, and it's hard to draw dotted lines in, but the x-axis is called the asymptote because the curve gets closer and closer and closer to the x-axis, but it doesn't touch it. Now, to draw that line I've drawn in green is pretty difficult to see, so we don't tend to do that. What we do is we say there is a horizontal asymptote. Horizontal means horizontal line. Asymptote, there's your horizontal line that's an asymptote. And where is the horizontal asymptote? Well, it's this line here. Where does that cross over the y-axis? Crosses the y-axis at 0. So there's a horizontal asymptote, which is the line y equals 0. And then you don't have to draw any of that line I've done in green there because you've labelled it here. So let's continue and see if we can actually make sense of some examples. So the first one says, complete the table of values and use it to plot the graphs of y equals 2 to the x, y equals 3 to the x, y equals 4 to the x. So I'm going to use 3 different colours here so we can see the graphs as we produce them. So what is 2 to the power of negative 3? Because that's the first one we're doing, 2 to the power of x. I'm going to do this row here first. So 2 to the power of x, 2 to the power of negative 3. If you put that into your calculator, or if you can remember indices, which you probably can't, that's 2 to the power of negative 3 equals 1 over 8. We will write it as a fraction, not a decimal, and your calculator can do that. You may have to hit S to D depending on what mode you're in. The next one, 2 to the power of x when x is minus 2. 2 to the power of minus 2 gives 1 on 2 squared, which is a quarter. The next one, 2 to the power of minus 1, gives a half. The next one, anything to the power of 0 is 1. The next one, 2 to the power of 1 is 2. The next one, 2 squared. The next one, 2 cubed. So that's my answer for that row. Using your calculator, see if you can do the next 2 rows as quickly as you can. I'll just pause for a moment. So I've put the answers there. I've just put them into my calculator or use my head where I can, so we can generate the answers. So I'm going to produce all three graphs now. So let's focus only on the y equals 2 to the power of x graph. So I'm just doing this one. So the first point I'm going to plot is -3 up 1/8. Well, if I go out 3, it's 1, 2, 3 to the left, up an 1/8 is really hard to graph. So I'm just going to guess it's roughly about there. The next point's -2 up 1/4. So -2 up about 1/4 might be about there. The next one, -1 up 1/2. The next one, 0, 1. The next one, 1, 2, 2, 4, and 3, 8. When I join those, I get this. Something like this. See, it's heading up quite steeply. I'll just put an arrow to say it keeps going that way. Arrow there. Really shouldn't touch the x-axis if I can help it, because there is a horizontal asymptote, which is the line y equals 0. Doesn't touch the x-axis, in other words. So if I now look at the blue graph, go to -3, 1 on, oh, that's next to impossible to draw. -2 1/4, next to impossible again. -1 1/3. Aha, that one's easy. 0, 1. Go out 1, up 3. Go out 2, up 9. And this point, out 3, up 27, goes off the graph. So my graph looks something like this. It actually comes in underneath that one. Then it heads up far steeper. So there's my blue graph. When I look at the pink graph or the purple graph or magenta graph or whatever color you want to call it, when you go to -3, 1 on 64, that's ridiculously close. I can't graph that. I don't have the scale. I don't even have the ability to write that finely with my pen. When I go to -1, it's up 1/4, so that's about there. So it actually goes underneath again, comes up, 0, 1, because 0, 1. Then I go out 1, up 4. So out 1, up 4. 1, 2, 3, 4, that's there. Out 2, up 16. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means I'm out 2, up 16. So it goes up and it's steeper again. So hopefully what you can recognize is the bigger the number underneath the x, the steeper the graph gets, and the bigger the number under the x, the closer the graph goes to the x-axis. Now typically we would just sketch a graph like this. And say there's my exponential graph, and we know it goes through 1 because you'll notice when x was 0, they were always 1 because anything to the power of 0 is 1. And that's what happens for all of the simple graphs. And make sure you mark the horizontal asymptote on, because when I actually mark these questions, marks are awarded for stating that. If you forget to say the horizontal asymptote exists and what it is, you won't get all of the marks for the question. Now, question 2 says to do the same thing again, but we're changing things up. 2 to the power of x, -2 to the power of x, and 2 to the minus x, and we'll see what happens. So I'll do the first one, 2 to the power of x. We've already done this, so we can actually do this one quite quickly. Anything to the power of 0 is 1. 2 to the power of 1, 2 squared, 2 cubed, and you can see that from the previous exercise. Now for this next graph, what you need to do is the 2 to the power of x, and remember just to put a minus in front of it. Don't go like this on your calculator. It's no bracket, we're doing this. And when you do that on your calculator, you'll get, get rid of those, you'll get minus 1 on 8, minus 1 on 4, minus a half. It's the same answers as 2 to the power of x, but there's always a minus in front of it. When you go to this part here, which is quite tricky, 2 to the minus x. On the calculator, you're going to put 2 to the power of minus 3, because the first one is 2 to the power of minus 3, which is in fact just 2 to the power of 3, which means that we can just put 8. Next one, do on the calculator, 2 to the power of minus 2, which is just the same as 2 squared, which is 4. And if you put the next one into the calculator, and the next one in, anything to the power of 0 is 1. The next one into the calculator, and the next one, and the next one, you should see that the top row and the bottom row are pretty much the same. They're just in reverse order. That's what that minus sign does. Let's look at the top row and plot that one. So we go minus 3 up an eighth, which is ridiculously there. Minus 2 up a quarter, it's rough there. Minus 1 up a half, maybe there. 0, 1 there. 1 out 1 up 2. Out 2 up 1, 2, 3, 4. And then out 3 up 8. 1, 2, 3, 4, 5, 6, 7, 8, about there. So that is y equals 2 to the power of x. Let's now graph the next one, which is minus 2 to the power of x. So we go left 3, whoops, we go left 3, but down 1/8. Oops, a bit higher probably. Hard to graph that accurately. Left 2 and down 1/4. Next one, left 1 down a half. Next one, left 0 down 1. Right 1 down 2. Right 2 down 4, and right 3 down 8. And when we draw our sketch, we see an exponential graph that's upside down. And the reason it's upside down is because there's a minus in front of it. You think of y equals x squared, got nothing to do with this, but it opens upwards. Y equals minus x squared is a parabola that opens downwards. Same thing happens for these ones. When you actually have y equals 2 to the power of x and y equals minus 2 to the power of x, they're the same as each other, just the minus makes the graph go downwards. Plus makes it go upwards. But what happens when the minus is part of the power? Well, it actually means things are going to go backwards a bit. So we go left 3, up 8. So left 3, 1, 2, 3, 4, 5, 6, 7, 8. There we go there. Then we go left 2, up 4. Left 2, up 1, 2, 3, 4. Left 1, up 2. 0, 1. 1, half. 2, a quarter. 3, an eighth. And we join those together. It's something like this. It's very hard to get it accurate, something like that, and it goes on forever. So when the minus is part of the power there, part of that power there, it actually does a reflection or a flip across the y-axis when I compare it to the original blue one. There's the blue one, flip it across the y-axis, That's what that minus in front of the x does. Now, I wouldn't expect you to remember all of this, but I do expect you to be able to graph it from a table of values. There is one more graph I could draw. I could draw y equals minus 2 to the minus x. So I've got two minuses, and you might be able to just pick from symmetry. It'd actually be upside down one of the purple graphs, something like that. Okay, so that's an idea of what's going on there. There's one more thing I haven't written yet, and that is I have a horizontal asymptote, and I've bumped something there, so let's go back. Oops. I have a horizontal asymptote at y equals 0 because that horizontal line crosses the y-axis at 0. That's important. You need to put that there when you're plotting any exponential graph. Righto, let's continue to example 3. Now example 3 is a little bit different because it's another simultaneous equation question. And it says, find the point of intersection of y equals 3 to the power of x and y equals 9. So because we're doing a simultaneous equation, we're going to sub y equals 9 into y equals 3 to the power of x. So everywhere I see the letter y, I'm going to put a 9 in its place. So it becomes 9 equals 3 to the power of x. Now this next bit, there is a mathematical way to find the answer quickly, but I'm going to tell you that you're going to use guess and check for the moment. And that's what will happen with these ones. 3 to the power of what number equals 9? And you can go through the process. You can go 3 to the power of 0, do it on your calculator. Anything to the power of 0 equals 1. 3 to the power of 1 equals 3. 3 squared equals 9. Hang on, let's stop, because if 3 squared equals 9, that means x has to be 2. And so we just use a bit of trial and error until we get x equals 2. And we just write down the answer then from that, because we just trial and error on our calculator or in our head if it's an obvious one, and you get x equals 2. Now, when x equals 2, I'm going to substitute back in. Is it easier to substitute into that one or that one? Well, you could put it here, and 3 to the power of 2, 3 squared gives 9, but this one, you don't even have to substitute in. It says x is always 9. So when x is 2, y is 9. If you substitute it back into there, you get 3 squared, which is 9 as well. Hey, we're finished. That's actually quite an easy question. So the point of intersection is at 2, 9. Finished. Now, just so you can see what this would look like, you're not asked to graph it, but that is an exponential that looks something like this. Go through it one. The line y equals 9 is a horizontal line that goes through the y-axis at 9. And according to this answer here, that point there, where the line and the curve or the exponential graph meet, is the point 2, 9. So it's out 2 and up 9. So that's the process there. You'll be doing a little bit of guess and check with ones like that. So time for you to try some questions and make sure you enjoy the experience. Bye for now.